All right, I'm still admitting some student coming to class. Just hold on a second. So, all right. So the bad news is that they're only um like 35% of the objective for completed, right? Like I said, that we are not able to complete every single topic of the objective four within 1 or 2 days. You have to do it every day. Okay. And it will be due on um October 19. So we still have like 9 days to complete them. I don't recommend you to like do like 20 topics per day. It's impossible to digest a lot of this. Um, so we have no class next Tuesday. I mean, but if you have like class on Monday, still have to come on Monday. So class Tuesday class, October 14, follow the Monday schedule. So no class. Okay. I won't be here for sure. I won't be on Zoom. Yep. Yes, so absolutely. So then we're gonna have like the data date too. It's gonna be on October 17. So I would request you to please bring your own laptop with you, right? So the project must be complete within an hours and 15 minutes. So it have to be within the class time plus 10 minutes that you have to submit your Word file, right? So the project must be completed within 1 hour and 15 minutes plus 10 minutes submit Word. So please read instruction guide before we start up the project data data, right? And if you need help, definitely gonna help you. But like I said, it should be within the time frame, not to be considered late because when you get your objective, when you get the data date late, you can only get maximum 18 out of 20, right? So we really want to make sure that people do well on the data dates of this class. It's very important. So late submission only gets at most 18 points on the project. Okay. On the data day. I don't call it like a project. The project is like big project, it's data day. And after we get the data day done on Friday, then there will be an exams. Exam two, like cover like if you do the objective like three and four, and then you just screenshot all the question, something like that, and then you study on it, I don't see any reason that you get lower than like 85, right? So all the questions should be coming from objectives three and four. So the exam two gonna be on um next the following Tuesday. It should be on October 21st. Okay, so a very important thing that the data date for, I'm sorry, the objective for is due like 2 days before the exam. Have to be 2 dates so they can study the post objective and all kind of things, post knowledge check. That's very important that we should have before the exam. 18 question. On Sunday, uh, I'm sorry, October 19. So the exam has 18 question, like we have like similar format on for the exams. Each question has a number of points. You're not required to submit your work unless you want to do that. So when I look back your question, you have a little complaint about the exams question. Let's say I got some, like decimal point up, I might give you back that point. But generally, you don't have to submit your work as long as you get it right, you get the full credit for it. It should be include like a short answer question, like fill in the blank question, not short answer question, I'm so sorry. Fill in the blank questions and um, you know, multiple choice question. Yeah, it's vital to complete the objective on time because I'm keep on reminding people they only 35% of of the progress that people made. For the objective four, some people only start 5%. Some people just start like 2%, some start 20%, some finish 100%. But overall, this is not, satisfied. Uh, you know, um, this is not a good satisfaction sort of for the course grade. So now let me just complete the thing that we have for the objective, and then we're going to move on to the exams review. So exam two review, which what we're doing today. Make sure that it's literally for like for objective three, we should know about the you know uh correlation, the positive, negative correlation. I'll give you some questions for that. Something like that. And then how we're gonna get the least square line, which is y equal to mx plus b. How we're gonna read that part. And question number two, you should be able to complete the residual based on the difference between uh the data sets minus the predicted data sets, right? Data point minus the predicted data, right? Predicted, right? Values. It's very important that we should, and then display the residual on the graph. Yeah, something like that. You will not be asked like to get the line, something like that. It's going to be very complicated, but you should know what it is. Objective four. For example, that the first one you have to know about the Shepherd theorem. There's a little T in the front. I'm sorry. Using 1 minus 1 over k squared. The k is simply the number of standard deviation.
Because variables we don't think about. So let's see about the coefficient. Let's see, 1.5 and 1.5 into 16. So 1.5 is divisible
Yeah.
by 5.
So this one is simply like times 100%. The K will be called the number of data points, right? I'm sorry, the steps, right? The number of different steps
So let's
of steps of the standard deviation.
two is let's kind of put that. It doesn't seem like we can have like an easily.
All right. So the next topic that we have will be with the empirical rule.
The next thing that you want to think about is
Like
there any
so one standard deviation away will be 68%, like 68%, like one standard deviation away. We have 95%, which is two standard deviation away from the mean. And then we also have 99.7%, so that would be three standard deviation away from the mean.
so yeah,
It's very important that we recognize this pattern because there'll be at least like three questions based on the empirical rules. So I really want to make sure that people get it right. Like one standard deviation away from the average was 68%, two standard deviation away from the average was 95%, and three standard deviation away from the average is 99.7%. And after that, we're going to deal with a lot of them, right? Like some basic probability rules,
um,
conditional probability, right? And uh, in John probability table. All right, it's like John probability, right?
so that means that in terms of the variables, it could actually be
And then we also have like cover some of the normal curve, the standard normal curve.
because we could be writing
Z, and then we also have a normal curve, like normal distribution, using Z-score, something like that on the calculators.
so that means that we have to look at the coefficient.
And then after that, we're gonna have
So and I will be right.
The last one like given by the Z given by the probability, uh the mean and standard deviation,
Because both of them are
magnify X.
right.
Okay.
So let's see.
Magnify
1.5
X.
it should
Using the formula which is X equal to
I'm gonna give you guys big numbers to square. So 125
equal to the Z times the standard deviation times plus the mean. So that's fairly important that we have.
5 times 5, 129. So that means that this is 5 cubed. Okay, so let's see if 216 is also some number cubed. It's okay. It's has to.
Plus the mean.
Like like this as well. So in this case we have 216.
All right, so that's very important. We should have those topics being answers.
Difference of cube. So let's first focus on rewriting this correctly so that it's cleaner.
All right, so let's go back to I don't think this one is actually is really important, but you know, just understand what it is. It's increase, decrease.
Remember power rule. So x to the second.
I also don't think this is very important, just simply understand how the graph looks like. Yeah, so this one we can figure it out whether it's negative correlation, positive correlation, and no correlation, or it has some non-linear correlation. So that's simply what we have. I don't think that's mattered too much. Yeah, this one is really important because we need to understand like which one is the correct answers. Um uh
right?
um
So
this.
the last step, kind of like writing these guys together is we want, remember that our special
Yeah,
forms
so this is
of
actually pretty straightforward. Like,
have two elements.
so for example, he doesn't find any,
When we
does
spot
not
something like
indicate
this,
that chai has
the first
more
step
or less mappability, so we
make
have
sure
no
we
correlations. As simple as that.
rewrite.
And
So,
then, so it's found that when customers buy bread, they tend to purchase more rice, something like that. So they have to be some correlation,
so that means that
but there's
we
no
don't.
correlation. I'm sorry, causation. I'm so sorry about that. There's no causation. The same thing being tall imply that a player has a faster serve, so that's basically some correlations, but there's no may or may not have any causation, though we have no
This, this was our end.
we have no like we have no like no idea what it is. So the same thing, they may or may not have causation, so we cannot claim causation from the questions.
5x squared.
Okay, so we just say may or may not be. So very simple. If there's no relationship,
This whole thing.
um,
Yeah.
if there's a relationship, right, and then we just say may or may not
Six.
have causation. As simple as that. You can't, should not do anything else. Just pick the one that come with cause may or may not have causation, because there's no idea that if that cause something to happen based on that relationship. So we can't really tell, you know, whether or not they have causation. So this is one thing that we should pay attention to.
So it could look like we have a difference of squares, but if we look at 5 and 6, we see that we can't, there's actually nothing that we can do further.
Yeah, this is also somewhat very important. Like,
Well, let's first rewrite this. We're gonna have 5 squared, 25, x to the fourth.
so the question gives you the long equation, and then you can say the mean of the birthday tends to be like based on the slope, and then we can also based on the line, you can just plug in the x and solve for the y. So that's very straightforward, right? It's literally not something like really hard on the exam based on some question like this. All we have to do is just simply read the questions and then answer accordingly.
So we're dealing with two variables.
All right, so the bottom part was like, you know,
Is there any? Right, we talked about, so if we were to.
so this one's based on the slope of the line, so it's simply the regression line.
Square of a sum, right? We can't be in a situation where we have a plus b squared, because we already kind of dealt with that, and we already said that here we're gonna have ab, not two ab, right? But this would be equal to.
So the same thing for that. If you given by the
Right, and right now.
equation, we can always
That's it. So. I think maybe.
you can always look
there's
at
really
you can
nothing-
always look at it and then see what it is.
Something. But then that.
It wouldn't be that hard on the exam for this kind of questions, and all we have to do is just plug that in.
What we could try and essentially, just.
Okay.
Almost treating these. As if we were treating a quadratic, so by the way, this is more complex, definitely more complex than I would put it.
Okay, just plug that in, take like 8.49 minus minus 0.29 times 3.4. Okay.
And 25 squared plus 30.
So we should get this one like 7.5. Yeah, something like that is very straightforward. And then the same thing for that, you might take like um 8.40, 8.49 minus 0.29 times 7.8. Yeah, we can compute it by yourself. You got 6.2.
Kind of gone for
Yeah, so those question was like very, very straightforward. I don't think that's the problem to us.
something, computation that looks somewhat like this, right? This is again, the reason why I could never put something like this into the ground. This is required.
Yeah, this one will not be on the exam because you will be required to sketch the line
Let's see, so.
and then, and then just based on that, you answer the question.
So that means that we would need, or sorry, 36.
And also this kind of question you need to do like compute it, send it to the take the sample, send it to the calculator, you have to compute each of them. It's gonna take very long to answer the question.
Yeah, so the bottom line is that this is.
This is also a really good question where we need to observe the midterms. The observed values is based on
I would work through like light.
the graph.
But, fair enough, in this situation. Mhm. Okay. They just. You're good. Okay, yeah.
So all you have to do is just like we given by the observed value. So when x equal to 12.1, something like that, this right here. So the y value is 70 is very straightforward. So we have the same thing when the x equal to 15 and the observed value for y was 65. So based on that, we can, like the predicted value was kind of different. In order to find the predicted values, we have to plug in x equal to 12.1 into the equation, which was given from the question as well. So you will not be required to find what it is. The equation of best fit, for example, is right here. You have to plug that in, right? So plug in the equation. So let's say we take 4.3 times the x was 12.1 and then plus 11.12. 11.92, you're gonna get 63.95.
So find yourself in a, say that you find yourself in a, let me think what a problem like that.
Okay, the same thing for that. We can also do like 4.3 times 15 plus 11.92. So we should get like 76.42.
Okay, yeah.
So that's what we have for the question, like for the predicted value based on the model. And then finally, the residual can be computed by taking the difference of the observed value, which is coming from the data value, was data value minus the predicted values. And then you can also compute it by taking 70 minus 63.95. You can see how much different of each values from the real value, the real data set values. This is going to create some margin of error. That's necessary in statistic because the line just only reflect the trend of the data set value, but the actual value just go differently. Our job is to actually minimize all the error bound. So which is why we have the line right there. So once we compute it, you're gonna get this one equal to 6.05. The same thing for that. We can do the same thing. We pick 65 minus 76.42. You get 11 - 11.42. So that's what we got from from this question.
Here that there is one way that you
And then we need to interpret like the plots as well. It's just simply based on the
say that you have
a certain plot that we have.
cannot write that f of infinity or thing is like plus or whatever it may be, that proportion. Because infinity is not is not a value that you can attribute to a function. So this never. Anything else? So say that as long as you
So let me just point out like some plot A.
say you have 3x4 plus,
And then we also have like plot B or something.
say that as long as you somehow, as you in one way or another tell me, okay, so three. Wouldn't that be yes.
And then we also have like plot C.
X is approaching minus infinity.
All right, so
So
how can we determine the plot correctly? So for example, we have the plot 8. The first point is below the predicted value, so this should be below, it's right here. Okay. So the first point below, the second point above, and so on and so forth. It should be like this. Okay. It should be this one. On the other hand, so something like the first one below, much below the predicted value, the second one much also below the predicted value, so it should be something like that. And then also the last point was like the first one is actually on the predicted value, so it's 0. So when you graph the residual plot, it's 0, and then the second point slightly below the predicted value, it's slightly less than 0. The third one was like above the predicted value, so that should be positive, right, on the residual plot. So this is basically positive. All right, so doing that can basically help us identify the plot corresponding the curve that we have. Okay, so that's basically what we have to do.
one goes up and the other on the other way is up.
This is also very important question. I want to go over that. This is objective 4.
If instead it's on, then that means that whatever the situation, one is down, the other is up. Okay? If the coefficient ends up being positive, then that means that I start with down and I end with up.
So
If it's not,
you have to pick the right curve. So this one must be the curve that we have to pick because it looks symmetrical.
look at a mental table in your head and choose the one of the four scenarios.
Since I don't really have time to solve for every question, so I simply just copy and paste so we can literally check. So the region A is basically approximate normal. It's something look like that. So if the shade was to go like this, is it basically approximately normal curve. So we can apply the empirical rules and see what it is. Um, so the question gives like the mean equal to 22.75. You can get like the K, okay? The K by taking the X. We can take the second part of the X. We take we take this one, 40.51 minus the mean was 22.75. Take the X right here. And we divide it by the standard deviation, which is given from 5.92.
bigger or smaller. But getting more and more, it's just this guy.
So we just simply like compute this on a calculator.
You know, equal. If it's even, then it.
So we take 40.51 minus 22.72, 75 over 5.92. So we got like 3. We basically apply these tricks most of the time. So when k equals to 3,
If it's smaller, you flip. Both small, both things are small.
stations, well, there's no way we can determine that causation based on what we have. I'm so sorry I didn't read the message, Rachel. Yeah, but it's also we need to study further whether you have to know if one thing that caused the other thing just to happen. Yeah, so it is one thing that we need to be extremely careful, right? And then we cannot there are many situations that we do not know whether or not like one thing that caused the other thing just happens. Which is why we can only maintain like objective idea that, the things may or may not be causations. So when k equals to 3, let me just continue on that. It will be 99.7%. Uh, so this is what we have for 68%. K equal to 1 is going to be 68%. So all we have to do is just simply take the mean plus this one standard deviation, right? We just 1 times the standard deviation. So we take the 22.75 plus 5.92. We got 16.83. So we do the same thing for that. We take 22.75 plus 5.92. So I'm sorry, one is minus. I'm so sorry. One is minus, one is plus. I should get 28.67. It should be it always be like one standard deviation away from the average. So we have to take 1 minus, 1 plus to get to the final answers. And this essentially going to give me 28.67.
Clearly we're dealing with a very big, like high period.
Okay, so always be like 1 minus, 1 subtract,
So that.
or 1 standard deviation. So that's gonna tell us like 68%. All right, let me just go to the next questions quickly. Yeah, Shepherd theorem is also very important theorem.
That means that
I don't really have time to solve it, so let me just do this. I'll show you how to get it done.
and we take out some big factor out of this, well, we have H2 actually here.
Oops.
But we don't have enough. That means that we can do that. Well, that. Yeah, but you can take out actually the force out of this one, you have to take it out of this one, which is fine. You can take it out of this one. So that means that this is not viable.
So the Shepherd theorem says, well, the question gives the mean equal to the mean was like 40 years old, something like that. And then
one of them
the standard deviation was 11.
And the highest one is gonna have to be.
So all we have to do is just read it carefully. And then, so you want to see like the number of K that we do. So we're gonna take 60, 56.5, right? So we need to determine the K. You need to find a K. And then the Shepherd theorem is kind of different. Like it's gonna be like it's gonna occupy 1 minus 1 over K percent at least of the data sets.
So
it was 100% of the data. We follow like that distributions, and then we just simply compute the K. Like I said, that we're gonna go for like 56.5. We take the bigger values right here. or you can take 23.5, doesn't matter. Minus 40. Remember, this 56.5 had nothing to do with the answer that we have. It's just the value that we just need to plug that in. Over the standard deviation that we had was 11.
When we have a monic, or when we have basically a quadratic polynomial that.
Then we can literally just do it on a calculator. We take 56.5
That makes it easy because
minus the mean was 40 divided by 11. So you got 1.5. After we solve for k equals you have to plug that into the formulas. And then so you're gonna do like 1 minus 1 over 1.5 square.
so you have to go by top, right? That it's either these two, or sorry, it's either these two.
So we can simply just do it on a calculator. You're definitely gonna get 56% based on that. You're gonna take 1 minus 1 over 1.5 square. Oops, so sorry.
Minus one plus minus one.
Okay, so you're gonna get this one is 0.555, something like that. This one is like 0.55555 or 56%, right? All right, the same thing for that. We're gonna do like you can find a k based on the Chebyshev theorem. So the k can be computed with taking the bigger x values. We can do a small x, but you're gonna get some negative value for the k, you know, and then you're gonna go for 62 minus 40 over the standard deviation equal to 11.
Like something, right? Always gonna be something.
So we got this one equal to like 22 over 1 is 2. So the standard deviation equal to 2, we're gonna take 1 minus 1 over 2 square.
I know that I'm looking for values that are right here. Right. So
like 1 over 2 square is like 1 over 4. So 1 minus 1 over 4, 3 over 4, or so you get 0.75 or 75%.
So the last thing you want to do is put.
Okay, so making sure that we get it right. All right, so the review was kind of long, so let me just double check. I think that's very straightforward. If I had the z-score, like take the x minus the mean divided by standard deviation. So I think it's very straightforward.
The job is actually not done because this is a difference of squares. So we would actually.
This is also a very important question. You can simply also find the z-score based on that.
Takes a while. These are the longest types of problems that I could give you.
I'm sorry.
Like you kind of have to. You have to know multiple types of special forms, and you have to be able to swap them. Like, this is also not going to be like you're not going to find like common problems and anything. Most of the factorization problems that I'm giving you are pretty like.
So you can find the z-score equal to x minus the mean divided by standard deviation.
Fusion, and then when I'm done with the fusion, I also have to do like I have to use my knowledge of special forms, and then special forms again is actually do like a plus here. I'm not going to use something like that for like maybe one problem. I can't remember if that happened.
Divided by standard deviation in this case.
But the bottom line here would have been that once you factored this guy into.
All right, so the x that we have was like the x was given by
Knowing that we're dealing with multiplications and we have the same, we know that whatever we do with this one, we're gonna do
the x was like so do we have the mean equal to
this
225. The standard deviation was 31. And then the x was 280. So this is what we have for the x. So we take 280 minus to 55, all we have to subtract the mean divided by standard deviation.
Anything else I can here? Yeah. Here I can.
So we should get the z-score equal to 0.81 in this case.
And then I still have this guy that I unfortunately cannot get rid of, but that's it. So, okay, now I've reduced this guy to, this is
Yeah.
as far as I can.
And then all we have to do is just like, it's 0.806. So we can just simply route up to 0.81. So this is what the question asks us to do.
All I have to do, put everything back together because we only.
And then, so it's what it means, like, it's that we 0.81 above the standard deviation among all the theaters, all the thing that we have, right? So that we like 0.81 standard deviation above the means, right? So this is what it says about the z-score.
And the very like last thing, if you want to like, be like.
All right, so I believe that's what we have.
Then like estimate of one times estimate of one, so I'm really.
And somewhat this question was really important. Let me solve first. I don't have time to do the rest.
You can also, if you read this like this. I don't forget either. This is just like, it's good if you notice that, okay, I can also like just kind of. I'm just dealing with.
So we just simply compute like the z-score between for Jenner and the bar, right? So you can figure it out. So the mean was, so the question gives us different mean and different standard deviation for both, right? We just want to compare them relatively what it is. So this one have a different mean, and this one have different standard deviation, and this one also have different standard deviation. And we have different x values. So this is like, so this is what we have for x, and this is what we have for x for the bar, and then we just simply compute it respectively. Let me do one calculations quickly. So you take the z. So let's say for Jenner, I can take 51 inches tall minus the mean with 53.5 and divided by the standard deviation. So that's like that says 1.3.
When you have a right triangle between a triangle that has.
So we can't just simply compute it on calculators where we have to take 51 minus 53.5 over 1.3. So you got this one is negative 1.92.
The longest side. Let's call that,
Okay.
call that C. Then we know.
So, and also that we computed for the bar, that gives like negative 1.17 if they're both negative or both positive.
This is the formula that you want for that kind of problem. Why is that?
Well, positive, right? So there's no unclear like whole shoulders, like who's taller relatively to to their populations. So we just say it's unclear that a student's shoulder relative to her population, right? So you have to be really careful about a question like that. And then this one is like very straightforward, like it said, which ones. Yes, so if one is negative, one is positive, you can say that if one is negative, one is positive. We can only we can only identify, we can only compare them, right? Relatively compare them.
Let's see. What are the
If like one is positive and the other one is negative,
well,
I don't have enough space, and the other one is negative.
well, you're that this in this case.
Let me just give you some example for that. I'm going a little too. I don't have time for that actually, so I'm just simply move forward. So this one is going to be the same thing, like the 72 percentile, meaning that so Brian actually sell more, of course, or higher, right? So basically 72 percentile meaning what? The about 72% of the sell people actually making lower values than Brian. So Brian was doing a really good job. And then Maria, the same thing, is 29 percentile, meaning that about 29% of the sell people actually make less value than Maria. But of course, there'll be 71% percentile of the other people going to make more value than Maria. So this is what it says. Okay. Yeah, I mean, this one is straightforward. I don't see any reason that we go over that. Yeah, this is also very important. Like, uh, let me just copy the answers quickly so you can, I don't necessarily have to do it.
It would take a while to work this out because the numbers are very big. But basically, in the end, you will get a quadratic equation.
So what is a Rete frequency? You're simply looking for the probability as well.
And from that, you know how to solve it. There's factors.
So you can just look for the P equal to computer science majors. Computer science major, we take 26 plus 16 over the total number of student, which is 316 student. I feel like that's pretty straightforward. I don't see any reason to go over it more. All right. So
But that's kind of it's always just
same thing for that. Like,
basically you have um one formula that you want to remember. It could be the
so let me just solve it first.
um Pythagorean theorem, or it could be like say if it's a rectangle, it's gonna be width times length, which is supposed to be area. And you'll usually be told what the area is and something about the width and length.
So apparently that this one is who had advanced degree, so we only look at the total number of advanced degree that we have. So we don't really care much about the rest of them, the conditional probability.
And then you'll get
Is conditional
the only difference is
probability. So the total advanced degree, like total advanced degree.
quadratic is going to give you two, and one of the two is not
So you're gonna put though in like different classrooms. So you're gonna take like 40 plus 46 plus 37. So we have this one is 40 plus 46 plus 37. And then, so this is the knowledge that we have in advance. And afterwards, the conditional probability, just simply look at how many of them that has, um, uh, that's basically leaving the rural. So we just simply, we had 37 of them. So we take 37 over 1, 2, 3, so that the total number of people who got the advanced degree, and that essentially going to give us the 0.3 for sure. Yeah, it's very straightforward. I don't think I can go over that more than once. Yeah, this one also really straightforward from the question.
What I'm trying to tell you that you're because if you were going backwards in finding a solution. So stay with me for a second. For you have an equation in general, right, like this, and so that at the end this is equal to zero. Then the way we solve this is we ask.
So you can find a probability of student.
And
it's simply like picking a student is just add up a total number of students. So we got 24 plus 16 divided by the total number of people that we have. We got 80 of them. So we have to always divide it by a total unless the question gives us conditional probability. So the answer for that is 0.5. So we can also buy the sweatshirt and the student.
Right? What you're being told here is that this has already been factored. So the hard part has already been done. All you have to do is see.
So we're gonna take the sweatshirt was 16 out of 80.
For what acts this, right? So this is kind of like the self-explanatory, right? So x equals 0.
So most likely have to divide by the total,
4, 0.
except for part C. So we take 16 over 80, we got like 0.2.
It's factored. It's like it's the.
So the last one you're gonna find the probability was the sweatshirt given by the student.
Well, this.
So we basically know the number of students that we have on campus. So this one is given. It's a conditional probability, so it's given. So we know the fact that there was like 40 students in class. So we're not going to divide it by like the parents, like the total of parents as well. Just only look at the number of students. So there are 40 of them. So we just divide it by 40. And then on top of that, we just take the those who wear like the sweatshirt was 16 out of 40. And that got to give us 0.4. So if we have like P of 8 given B, so this is a given.
Well, when it's already factored, again.
You always have to take the joint between A and B, right?
When you have
A and B over
well,
like B over all student of like all the givens, right? Given B. So the B always be when the B was given, so we always write in the second part. Remember, we trying to find a student who wear the sweatshirt, but we know the fact that there was 40 students in class, so we want to put them into a different classroom, and then with 16 of them who wear sweatshirt. So this is what we have to do. 16 out of 40, we get 0.4. I'm sort of like running out of time, so um yeah, this one you can do it on your own, something like that. It's yeah, you can do it on your own, so it's not a problem for me. So let me just go to like some of the raw score, something like that. Yeah, this one kind of like harder for us to deal with. So let me just go jump to that. So we need to know that the question gives like the mean and standard deviation. So it was given by like mean equal to 230 and the standard deviation was like 20. So I'm using different marker, just making sure that we're doing what it is. So the standard deviation is 20.
So most of people are thinking, so vengono alle 8, ora mi fanno domande, quelli di qui siamo.
At 230. And the standard deviation is 20. So the question also gave us like a P or something. So the P says only 15%. All right, so we need to know like so we need to find the z based on that. Okay, so all we have to do is just like, well, this is, you need to know whether or not this is the only 15% of the female age 50 or over is higher than only 50%. So this is like low, right? Low cholesterol, something like that. So when we compute it, you're gonna take the x, so you need to find the x equal to the z times the standard deviations plus the x plus the mean. Okay, so you should get something like less than the mean. So in this case, when you took like 0.15, you're definitely gonna get something positive. So you making sure you're gonna take the z of 1 minus 0.15, and then times the standard deviation was like 20, plus the mean was 230. Okay, so this is what we have to do on a calculator. Okay, we're gonna take the z-score that we have, and then we got the answer equal to 209 point point 3. Okay. So remember that the calculators always give us the right area. The z's always gives the right area, most likely on the p-values, which we'll learn. So to get like below, like the bottom 10%, right? Which is the low, to get the low cholesterol, make sure that the z-score is negative. Must be negative. And the x must be less than the mean, okay, of 230. Yeah, this is very important. We should know. All right. And then let's do like a few more. I'll let you go.
Non so, secondo me è anche un po' parte di questa cosa per cui invece qua in America c'è anche in Italia in realtà, solo che
Let me just answer solve it first.
non so bene quale sia la differenza, però tutti vogliono una laurea. Non so, io non so per prima il medico deve fare. Se non è per te, se non riesci a passare.
So the question gives like the mean and standard deviations. The mean was 113. And then the standard deviation was 16. I'm always use two different marker. So you want to have less than 109. That's for x. More than 137. So you want to have like the p of x was less than 109 plus p of x was more than 137. So this one I'm gonna do 1 minus. Okay, so now we can use the z-score on the calculator to compute this. The probability of a z and then we take the divide, take the x is 109, subtract the mean was 113, divided by standard deviations is 16, and then so let me just do that on a calculator, making sure we got this part first. And then we're gonna add, to add like 1 minus we do the same thing. The probability of the z that we have is 137. Subtract the mean was 113, divided by standard deviation 16. But like I said, this also be on a calculator. Okay. And then you should be able to get it, which is 46.81. 8.468, something like that. It should be one line answer for that, even if because we allowed to use a calculator. So yeah, the probability can be computed based on two different area of the z-score. You can just simply just convert to the z-score, like taking the x minus the mean divided by standard deviation, and the other side just take 1 minus the p of z, something like that. So that even if it's quite advanced, but it should be one line answer. If you break it down to two different calculations, that's perfectly fine. But it's gonna give you something like you have to route up to a decimal point. This might be a little confusing. But anyway, all right. So I feel like that's pretty much for 2 days. But I hope that you guys are going to remember it until the following Tuesday on October 21st. Don't forget to practice those post knowledge check. Those are very important. All right. I feel like that's pretty much for today. We did a lot of questions. I mean, I can't really go over the entire, like review. There's so many topic. I can't really do that. Yeah, maybe you know how to shape this using calculator, z negative 1.5 to the left. It's 1.5 to the left, something like that, to the left side. Yeah, something. And then you can solve it quickly using a calculator or using this something like that. Is yeah, you should know how to do this part. But anyway, I finished the lecture today, the exam review today. So I once we meet up on Friday, we're gonna have a data day. Let me just take attendance real quick. I'll let you go. Um, Jasminer is here. Malika, Malika is here. Okay. So Jazz is not here. Annie, got you. Rachel, Selena. Yeah, you can look at the names over here and just type yes. I'll let you go. Hashan, got you. Saminer, Sarah, Alexis, Z, Maureen, Maureen's here. Maureen Garcia. Oh, Jocelyn, Valerie, Nadir, Nadir, not here. Oh, I'm sorry. Nicole. All right, Tina, Ariana. Yeah, you can look at the names on my screen. I should be able to see it. Okay. Um, yeah, I think Nico's here. Karen, Meter. Okay, Karen's not here. Amammer. Got you. Lisa. Okay, Lisa are not here. Chair. Oh, yeah, this you're the Zoom user. I literally have no idea who you are. Okay. Katerine. Okay. Uh, Chloe. Got you. Elkin. All right. Um, yeah, that's a hard name to read. Yelly. D Dahmers. Okay. All right, guys. So, William, Lenny. All right. So, guys, so have a wonderful weekend. Make sure we have no class next Tuesday. I want to see each other again on Friday for the Daddy Day too. And afterward, we're gonna have the second exam. Okay. Have a wonderful weekend. Take care.